We can specify delays in our HDL, but this is super important. Delays are only for simulation. We don't specify the delays of the hardware itself, but these delays are specified for simulation so we can see cause and effect between signals. So here's an example SystemVerilog module called example, and it has these delays. Delays are indicated by a pound sign and then the delay amount. So in this case, this would delay 1 tick or whatever is specified, so typically like a picosecond of delay. But this is just in simulation, so again, that picosecond really doesn't have any physical value. It just helps us see our simulation cause and effect in the circuit. So let's dive deeper into this. So here we see the simulation, and we're going to see some delays between the signals. So let's look at that in more detail. So here we have our module has inputs A, B, and C, and output Y, and then a bunch of internal nodes, AB, BB, which are A bar, B bar, CB, C bar, and internal nodes N1, N2, and 3. And so here we see a sign, and then we add this, pound 1 indicates after 1 clock tick, this is again simulation only, a sign after 1 clock tick of anything on the right side of the equals of the sign statement changing, then change the signals on the left side. So that pound 1 says anytime A, B, or C changes, 1 clock tick later, change the values on the left side. So we can see that at time t equals 0, A, B, and C transition to low. And then 1 clock tick later, we can see this on the bottom, we have 1 clock tick later. We can see that A bar, B bar, and C bar transition to 1, to the inverse of A, B, and C. Okay, again, this is in simulation only. And now we can look at the next lines. So we have these lines here where we have this pound 2. So again, whenever anything on the right-hand side changes, 2 clock cycles later, or 2 clock ticks later, the signal on the left side should change. And so here, for example, A and B changed at time t equals 0. So 2 clock ticks later, N2 and N3 should change. And so we can see that in fact N2 and N3 changed. And because it was an AND relationship, we had 0 and something, right? Because A transitioned to 0, and so that they're in an AND relationship here, 0 and something, 0 and something. So the simulation tool could evaluate that and say, well, it doesn't matter what those other things are. That would force our outputs, our N2 and N3 values to 0. And then this statement here, assigning N1, depends on inputs A, B, A bar, B, B, B bar, and C bar. And so that responds 2 clock ticks after those change, which is at clock tick 3. Right, A bar, B bar, C bar change there, 2 clock ticks later, and 1 changes. And now we have the final output of our module should change 4 clock ticks after any of these change, N1, N2, N3. And so we can see that N1 changed here, and 4 clock ticks later, Y changed because it's an OR relationship. N1 changed to 1. We have 1 or, well, stuff. Doesn't matter what those other values are. 1 or anything is 1, and so Y evaluates to 1 4 clock ticks after N1 changes.